Hello students, we now look into solve problem number 5, which is a problem on design of multi-plate or multi-disc clutch. So let's look into the problem statement in the next slide. Okay, as we have discussed in the previous video, I have provided the figures for the multi-disc clutch here. You can, I think you have understood by now how a multi-disc clutch will work. So let's move on to the problem statement in the next slide. All right, so this is solve problem number 5. A multi-disc clutch has 3 discs on the driving shaft and 2 on the driven shaft. The inside diameter of the contact surface is 120 mm. The maximum pressure between the surface is limited to 0.5 Newton per millimeter square. Calculate the outside diameter of contact surface for transmitting 25 kilowatt power at 1575 rpm. Assume uniform wear and coefficient of friction is 0.3. All right. So it's a very simple problem. You just have to find out the outer diameter of the uh, clutch plates, which is DO. All other data we have. And again, I think they have asked us to make use of the uniform wear theory. All right. So very simple problem. They have given us DI and we need to solve for DO. Uh, you've got 5 discs here, 3 on driving shaft type B and 2 on driven shaft type A. Therefore, total number of plates is 5. All right. So let's look into the solution in the next slide. All right. So this slide here gives us the data. Z1 is 3, that is number of plates on the driving shaft. Z2 is 2, that is number of plates on the driven shaft. Okay. Therefore, total number of plates N is equal to 5. Inside diameter is 120 mm. Maximum pressure is 0.1 Newton per millimeter square. The power that needs to be transmitted is 25 kilowatt. RPM is given as 1575. Coefficient of friction is 0.3 and we need to solve for the outer diameter DO. So let's look into the solution in the next slide. All right, so this is a pretty straightforward problem here. Okay, all the data is given and you are supposed to find out DO, right? Now, to find out the outer diameter, since we know the power that is needs to be transmitted, you can find out the torque, okay, using the power equation, right? 9.55 into 10 power 6 into power divided by rpm n will give you the torque as 151.59 into 10 to the power 3 newton mm, right? So once you know the torque, okay, so the torque is known to transmit 25 kilowatt power at 1575 rpm. You need a torque of 151.59 into 10 to the power 3 newton mm, right? Now they have asked us to assume uniform wear theory, right? And for uniform wear theory, we know that the mean diameter is actually the average of both. Now we don't know DO, we need to solve for DO. Therefore, the mean diameter can be expressed as DO plus 120 by 2, where the inner diameter is 120 mm. All right. Now they have given us the maximum pressure value, right? Maximum pressure was given in the problem statement as 0.1 megapascal, right? Therefore, to maintain that maximum pressure, we can obtain the axial force by making use of the uniform wear theory formula for axial force as 1 by 2 pi p max di into do minus di. Now here again we don't know do, right? We know all the other values. Substitute and simplify this and you will get an equation for axial force as 18.84 into do minus 120. I'll name this as equation 1. All right. Now, in this problem statement, they have mentioned that the number of pairs of number of plates is 5, right? That is 3 plus 2, 5. Therefore, number of pairs of contacting surfaces n dash will be equal to number of plates minus 1. That is 3 plus 2 minus 1, which is equal to 4. Therefore, n dash is equal to 4. Right? Now, for uniform wear theory, we have the equation for torque as T equal to 1 by 2 mu n dash axial force into mean diameter. Right? Now, you know the torque already. You know that torque is equal to 151.59 into 10 power 3. Therefore, substitute the value of torque in this equation and solve for dO. dO will be part of both axial force as well as mean diameters. Therefore, substituting, the torque is equal to, if you will see here, you will there is only one unknown in this equation, which is the outer diameter dO. Now substitute this and simplify this, and you will get dO as equal to 203 mm. Right? So straightforward, you can directly find out the outer diameter. Right? So that finishes off this video. We now move on to problem number 6 in the next video.